All right, in this video we're going to take a look at welding of what we call toe bracket assemblies, and we're going to introduce the concept of wrapping welds and start to look at weld sequencing. I'm going to be running flux-core in this video. This is part of the flux-core series. I'll cover the same content for stick electrode as well in a separate video, unless you're watching the stick version of this, in which case it's the other way around. But my intention here is to show you kind of how to do these in the shop. Now, this is a crude drawing of what we're talking about. Basically, this goes back to when I was learning to weld at BIW. This is one of the standard assemblies that we did. It's comprised basically of two pieces of flat bar. All my, coupons, if you will, in this shop are a foot long for fillets. So this is 4 by 12 by 1/4 inch, just, A36 flat bar. And these are what I call runoff tabs. Again, it goes back to my time at BIW. But basically, these are flat bar 1/2 by 3 by 1/4 inch thick. And they're just a standard little tab, a standard piece that I stock here at Bath Tech. What it amounts to is essentially there are 6 of these tabs. I don't have them drawn on the back side, but we put 6 of these tabs on a T-joint. It is important to fit these up accurately. You can learn how to fill gaps somewhere down the road, but when you're first doing these, the students have welded basically horizontal and vertical fillet welds, no overhead as of yet, at least when they first start, although we weld these in all positions. But basically what we want to do is get our plates lined up. They don't have to be, perfectly centered. We don't need to get out layout tools at this stage of the game. When most people have done this for the first time, they haven't really learned how to use those. But we want to get this T-joint relatively centered up. Again, 1.5 inch, another 1.5 inch on the back side, plus the thickness of the plate. We're at 3¼ inches total, which only leaves us 3/4 of an inch left over total. So there should be roughly a 3/8 of an inch gap on the front side. So we want to make sure that we have that spacing in here. And if we don't, what's going to happen is it's going to make it hard to do the wraps, and that's really one of the purposes of this exercise. The spacing should be relatively uniform. I generally will go about 2 inches in from each end, and then I'll place another tab dead center. If you're looking down on this assembly, ideally the tabs will be lined up front to back, and they should be vertical. The tabs are often cut on our shear, so the flat bar isn't fed in straight. They're not really perfectly square on the ends, but you'd be better off to have a small gap on the 1.5 inch side than to have a tall gap on the 3-inch side. So take your time when you're fitting this up. And in the video, the actual weld footage part of this, I'll show you that process. Basically what we're going to look at doing is sequencing the work. So what we're really trying to accomplish here is welds that go up around the corners, and we want to put our wraps in. Now, wrap is, again, a BIW term. You get used to the area where you welded, and I think a common AWS term is to have the ends boxed, box ends. But again, the shipbuilding term that I learned was wraps. So as I'm welding, it's important that I start off right on the ground. I literally want to weld all 3 of these pieces of material together. I don't want to start above this deck and leave a slag-filled inclusion at the bottom. I want to strike my arc right there on the lower part of this assembly. And then I'm going to sweep my wire into the corner, and then I'm going to travel up. When I get to the top, I have to have that same weld, and again, we're going with a 1/4 inch fillet on these for practice. I have to have the same weld size around the edge. So if I had a huge thick piece of steel here, if these tabs were an inch thick instead of 3/4 of an inch thick, it would make sense that across the top here we would have a inch long 1/4 inch weld. Well, even though this is just a small edge, we still have to wrap the weld around it. So in terms of technique, by the time I get up into the upper part of this, I'm going to be at a situation where that sucker's getting hot, okay? Now, you've got to tune your machine appropriately. So if you look at the video on setting up, you may find that, some tips. But again, set your voltage, set your wire feed speed appropriately. If your arc is really long and you get up near the top of this and it wants to dig, then you've got to do something. At a minimum, you've got to pull the trigger and go squirt, squirt, squirt to fill up through the top. In an ideal situation, you would simply come up past the top, okay, literally a 1/4 inch above the top, and then move over. So you're squaring the end off, okay? In a realistic scenario, what typically happens is you get to about right here, and then you may have to literally angle your gun. So my initial gun angle is going to be something like this. I'm going to stop, I'm going to move the gun, I'm going to go squirt. I'm going to move the gun, I'm going to go squirt. So I'm going to bring that gun up around, and I'm going to actually give a quick little squirt, stop, okay? If you are keeping the puddle orange, not letting the slag solidify, and you're coming up around that corner on that wrap, when you squirt that, you will not bury slag in there. If, however, that cools down and that puddle turns black, then you got some issues. You're going to have to chip the slag off, okay? So if you can come up past the corner and then travel across to kind of box off that end, that's perfect. But if not, come up around the corner and again, while it's still orange, fill it in. We just don't want to see a little crater at the top of the puddle up here. I don't want undercut in this general area, right? Now, the horizontal, we're going to do something a little bit similar. Basically, in an ideal world, you just travel in, come around, you just one swift motion. But the reality is that's not realistic for most of us. So on the horizontal, I am going to try to travel, again, for arc blow purposes only. I'm going to travel from this edge in, okay? I will oftentimes travel from the wrap in as well. But if you can manage the corner and not get arc blow, it's a lot easier with flux-core than it is with stick, okay? So this technique will also work for stick. But if you can come in around the corner, then go for it. But you want to remember that you have to have that weld bonded to the bottom. You don't want to have a little shelf of weld with slag stuck in between the lower plate and the bottom of the weld. But I want to take a look at this section here real quick, okay? If we zoom in on that, you're going to see something. When you put your fillet welds in, you are creating a 45-degree angle, okay? Ideally, that weld is in at a 45-degree angle. Even though that weld is small, you still want to take that into consideration, because by the time the vertical weld is 1/2 inch or 3/4 of an inch, there is a definite corner. So when you're traveling, you want to make sure that as you continue to travel down to that corner, that you actually pivot at this point with your travel angle, and you actually rotate your gun, and then you travel across, and then again you pivot, and then you rotate your gun. So if you travel all the way in and out, you should have your gun angle roughly 90 degrees, maybe a slight push as you get in. So I'm going to travel in here, get to this corner, rotate, travel out, get to that corner, rotate, and then again travel out to here. Once I get to this lower corner, if I'm traveling away towards it, okay, away from the inside corner, then I'm going to have to scoot my gun around that corner to produce that wrap. I will probably have to come around that corner and go stop, squirt, to get a little bit of weld built up. So the lower weld on that inside should, in fact, maybe start down here. It's going to come in. There will be an actual transition, a transition, and then it will wrap around. Transition, and then wrap, transition out. Whoops, horrible aim here, folks, with my marker today. So there really should be a nice 45 transition in that corner. The alternative, of course, is to go in the other direction. If I'm traveling from the wrap in to the corner, I still want to weld around that. Again, I'm going to weld my verticals first. If I haven't already mentioned that, sorry, but you need to weld the verticals first, okay? We want to cross our T's. So if you think of this as the letter T upside down, I'm crossing my T. I have an airtight, oil-tight, watertight corner, not oil-tight by Navy spec. That would require 2 more passes showing. But I have a tight corner because I have A, bridged the corner on the very bottom before I went up, and B, I have completely sealed it with no slag inclusion because I started down on the deck and then I welded up, right? So as I'm doing this outside corner, one trick, and this is especially handy with stick, but also for flux-core, which is what this video is focused on primarily, is I'm going to strike my arc right on the corner. Okay, slightly inboard of the edge of that thin part. And then what I'm going to do is I'm going to pull the trigger and I'm going to weld. As soon as I pull the trigger, I'm going to go out, back, pause, and then in. Okay, so I'm going to whip out around the corner, back in, quick pause, and then in. That will allow me to wrap that end and then continue that weld in that direction. I'm going to do that from both sides. So even though I've already wrapped this corner from this side, I'm going to wrap it from the other side. I want to make sure that the weld is the same size all the way around this tab without undercutting it. All right, so we're going to begin the process of fitting this up. And essentially what I'm going to do is make sure this is centered by simply laying a tab on the front and another tab on the back. And then I can see visually that it's centered on the plate. Then I'm going to give a little tack. I should have approximately 3/8 of an inch of plate extending past the tabs on both sides, but just eyeball it to get it even. This is just a practice assembly that's going in the dumpster. Okay, this is not a product that we're building to blueprint spec. Okay, that's down the road. But initially, we just want to make sure that these are reasonably square. After that, I'm going to check it to make sure that it is square. You know, as I mentioned earlier, we can't count on the runoff tabs being cut square because they're just sheared. So I'm going to get it in the ballpark, give it a few taps, you know, use a hammer, whatever you need, and then I'm going to grab my combination square and I'm going to check it. And when it's square, using a combination square, not the tab, which is probably crooked, I'll start to fit the tabs in. So here I'm going to put the center tab in first. This one is cut pretty good. It stands up on its own. And I'm going to hold it at the top. I'm going to tack the bottom. I'm tacking the wraps. And that helps when the finished product is welded. Now, when I did this, I've got some grounding issues. I just kind of plugged through it to get this tacked up. So I've got some poor tacking going on here. And I'm trying to strike the arc off the bottom plate. The welds on these are only supposed to be a 1/4 inch in size. A little oversized is fine, but you start hitting 5/16 plus and you got problems. Notice I stopped at the top and I gave 2 squirts to help blend that in. Pay attention on the next tabs. You'll notice that when the puddle gets to the top edge of the tab and it starts to chew away the sharp corner, the sheared edge, that's about the point where I kind of stop and squirt from there. A lot of the students tend to just stop there and they don't actually wrap the top. So right there, the corner's gone, and again, squirt, squirt, maybe one more squirt. So I want to do that while it's still red, and that way I'm not going to bury that slag. So I'm going to go right across the entire plate here. Again, notice the weld will bridge the bottom, so we're actually bonding all 3 plates together. Now I'm going to roll my wrist to level the gun up, and then I'm going to raise the MIG gun up so it's not pointed downhill. Again, as I get near the top, just start to see right about now, it's starting to eat that corner, so I stop, squirt, reposition, stop, squirt, maybe one more from square on. And that way I get a nice weld that goes around that top edge. And that's what we call a wrap. Another shot on the opposite side. And again, we are traveling uphill and fire down in the puddle. You can see the arc, the shape of the bright area quite well. It's hard to see the wire itself in the camera shot, although you can see it by eye. And again, it's being careful to bring that weld up over the top. So as I'm going across, I'm just welding all of the verticals first, and then I'll come back and I'll start to fill in the horizontal ones. Now that doesn't mean that you have to do it that way, although you do need to weld the verticals before you weld the horizontals, because the purpose of this is to create a watertight or some kind of tight container. And to minimize the risk of leaks, we want to bury those cold starts with hot continuous welds. Now in some cases the weld may not go all the way through the corner continuously, and we'll take a look at that in a minute. But if you have to stop in the corner, you want to travel through the corner and stop from both directions. You don't really want to start a cold weld in that corner if you can help it. And again, this is in an ideal world. This is a training aid, and it doesn't necessarily represent real structure, especially at the shipyard, where you'd always have a snipe in the corner. But snipes will be a topic for another video. So again, as the weld comes up, look at the top, just starts to eat the corner away, and I'm going to reposition, squirt, and there we have it. So let's chip some slag. All right, so we're going to in. As I come around the corner, I'm going to, again, poke the wire around that wrap. I'm going to pause, give it a couple more little squirts. If I don't do that, I'll just melt away the edge of that small 1/4-inch tab. So it's important that you don't just try to plow around that corner. You don't want to cut away the 90-degree edges on that tab. Now as I reposition, I'm going to start on the outside and work my way through, but notice the verticals are bonded to the bottom plate, okay? That's important. If we don't do that, we'll trap slag under there. We don't want to trap slag under. So here I'm going to start on the edge. I'm going to whip out back real quick. And then I get to the corner, I'm going to turn 45 degrees, travel the other side of the weld, turn 45 degrees again. So let's look at this on the other side. I'm not just rounding the corner, I'm making a transition. So again, turn, weld 45 degrees, turn again, and then I'll weld 45 degrees if I can make it around. In this particular case, I chose to stop because I didn't want to drag out, throw spatter on the inside. So I'm going to start on the outside edge and work my way back into the corner. Notice that I welded through the corner to the opposite side of the vertical weld. I'm going to do the same thing from this direction. Again, a little whip out and back and wrap, and then I'm going to travel across to the opposite side. That leaves a nice full corner. Now we'll come along, we'll look at yet another section here. Again, pull the trigger, whip out back real quick. And again, watch the corner. Turn, 45, turn again, and now travel. Don't just, wind through those corners, folks. Make an effort to transition. The weld represents a direction change of 45 degrees, so try to do that. Now here, I'm going to go to the outside edge and work my way back in. The weld was hot when I started. It was only 1.5 inches away. I probably should have chipped the slag off on that inside corner before I traveled over it. But I didn't. Again, notice that small little whip out and back on that wrap. That makes that second side of that wrap nice and clean. And I'm not going to strike the arc on the edge because I'll just burn it away. So again, I'm striking the arc on the side of the plate and then whipping out and then back very quickly. So we'll go ahead and clean this up, see what it looks like. Pay close attention to the inside corners and the wraps when we're taking a look at this. Those corners should be full. There shouldn't be any slag. You should see signs of the direction change, the little 45-degree transition. So there's actually a transition in the weld as well. It doesn't just round through the inside corners. And they should look nice and clean. Needle gun would sure be handy right about now. Little end wire brush as well. But you get the idea for what these are supposed to look like. And they take practice. So be patient.